Yeah. Good afternoon, everyone. I'm Dr. Garam An. I'm working as a research fellow in the Manstein Lab, the CBRC. So begin, I'd like to disclose that I'm a shareholder of this company. And the content of today's presentation is related to several patents that were recently filed. So when we focally coagulate the dermis, then we can easily observe the aggregation of surrounding small areas of skin toward the center of coagulation. And these are some examples of planar deformation with centripetal contraction. So the immediate contraction basically occurs because collagen bundles in the reticular dermis are horizontally arranged, and the individual fibers get shortened above 60 to 65 Celsius. So when we hit one spot, then some range of dermis will contract horizontally. And while the surrounding area that didn't undergo the contraction will be stretched passively. So this presentation will focus on finding this boundary. So here's the model. So if we induce a focused heat spot, then the heat will dissipate outward, and there should be a specific cutoff radius in that collagen shrinks. And we're going to define the boundary as the radius of contraction. So if we define two arbitrary points as x1 and x2 in pre-contraction, and fx1 and fx2 in post-contraction, then the ratio of their distance pre and post-contraction would be less than 1, because that is basically a definition of contraction, if they were within the radius. And if they're out of the radius, then the ratio would be greater than 1. That becomes a definition of dilatation. So if the gap between them become very small, infinitesimal, then the ratio becomes the derivative of fx. And since the graph would be continuous, and the slope of fx at the radius become 1. So the graph fx, again x, would be below the line of y equal x, because there would be no element that goes further after like contraction. And it would begin with a slope less than 1, and the slope would reach 1 at the radius, then get steepened. Eventually, it will converge to y equal x graph, because the skin that is too far away from the center would barely feel the effect of central contraction. And the subtraction of fx from x would give us the displacement like this. And the peak point of this would have a slope of 0 at the radius of contraction. So for validation, we track the identifiable surface elements using a digital microscope like this, and expressing the initial position as x and the displacements after contraction as y. Then the scatter plot from the tracking fitted very well with the log normal distribution curve, which is with a high R-square value. So this curve occurs when ln of x follows a log normal distribution, and the peak can be easily calculated from the data. So I repeated the same experiment 10 times. And the data consistently showed high R-square values, higher than 0.6. And we could compute the radius of contraction in all cases as well, very easily. In histology sections, from the radius, the collagen bundles start to diverge up and down, and the dermis begin to be thicker. And the interesting thing is, it seems that the horizontal contraction zone was much larger than loss of viability zone in the center. So it indicates that there is a significant area that the skin was horizontally contracted but still alive. So in summary, we can compute the radius of contraction non-invasively using the fact that horizontal displacement follows a log normal distribution curve. And in the radius contraction, there is a remarkable dermal thickening zone, and that is horizontally contracted but still viable. So Due to time limitation, I could only show you very initial phase of a series of study that began from a conjecture that there must be an ideal pitch distance for a fractional tightening treatment. And if there is, then we would be able to implement a design in plane contraction as well. So in this image, I used lowest density, the lowest density mode of the CO2 fractional laser. But the loss of viability zones were densely packed adjust to each other, unnecessary. So further studies include delayed biological response after this model using clinical trials and investigation of other various energy sources on this model. Thank you for listening.